All right, the first topics that we need to review is the limit. So you want to jot this down somewhere. It's not going to be in Paradox. I will share this document with you as well, so you have it. Direct evaluation. So limit is, remember when you have a graph, when we talk about limit. When we talk about limit, if there is a graph, okay, and I have this graph is going, I don't want that. That's not working. Let me review this. Why waiting? I'm just want to let, for those people who just join, make sure that you get a paper, take notes. So the first topics we can look at is limit, okay? And the first objective is direct evaluation. What that means is if you have a function, just plug it in and that will give you the limit. So that's fine. So what is limit? Let's review a little bit. If I have a graph, if this is my function, okay? Let's say I want to find the limit at 0. That is mean we want to figure out at 0 what is the y values. What is the closest values that is as x approaching to 0? What is the y values? Yes, I'm recording this lesson. So you should be able to go back and watch it. Yes, I normally share the link and I attach the link to the folder. I'll email you guys the link. If you check from Schoology, I normally email the link every day at the end of class, so you can find it. You can play it. Okay, so the limit is, again, this is something, it's been a while that we don't remember. So limit is as, so let's say I want to find the limit as x approaching 0. And I want to know the y, that is the y values that we talked about, okay? So in here, let's say that is 1. So the limit is 1 because as x approaching to 0, the y value is 1. So pretty much the limit is that y values. But we're not going to look at the graph. So because of the time that we have, you don't have to look at the graph and figure out the limit. But you should know the next 3 objectives for limit. The first one is direct evaluation. Direct evaluation, to find what is the limit, all I need to do is plug in the values into the x. So I look over here, this is my x values, right? X approach -2. So I will plug in -2 into the x. Whoops. So this will be my limit. So I'm just directly substituting the value. So limit, direct evaluation is simple. Plug in the values. Same thing over here, -2. Instead of x values, right? Instead of x values, I replace that with -1. -3. So this would be, whoops. So this would be 2 minus 3, so the limit would be -1. So that's the first objective that you should know for the semester exam. So there's no paradox. You can find this document in the semester folder. Click in that folder, you can see semester review, okay? And then the other one is semester exam, which I have not posted anything yet, so you shouldn't see those. The only thing you see is semester exam, semester exam review document. Okay, so you can do this on a piece of paper, upload that to me, or go to KudoWorks, log into KudoWorks and do the work. Then I will see your result. So any question for me on direct evaluation for limits? Okay. All right, so let's look at the next objectives is piecewise function. We want to find the limit for piecewise function. Piecewise function is when you have more than function given to you, more than one functions, okay? So to find the limit, how do I know which one that I'm going to plug in? This is the values that I'm going to use, Okay, the constraint, the domain, that's what they tell you what values I'm going to plug it in. So to find the limit, think about this. The limit is when the graph have to come to the same values. If we have this kind of graph, if this piece right here, and this graph has something over here, okay, then the limit, if they don't come to the same place, there is no limit. What we call is D and E. So that means the left limit and the right limit has to be equal. That's when we look at the graph. For piecewise function, in order for us to figure out what that is, we're just going to plug into the left, we're going to plug into the right, and compare them. If we have the same values, then there's limit, and that is a limit. If they come with different numbers, then we can say there is no limit. All right? So let's clear this. Let's plug it in. Let's do some practice. So I can say limit x approaching -2 from the right. Think about this, -2. This is -1, -3. So anything less than 2 would be the left limit. So I can erase this. -2. From the left, I just plug it in. -2 square minus 2 times -2 minus 1. So this will give me -4 plus 4 minus 1. So this is -1. So this is the left limit. I'm going to do the same thing for the right limit. So I can say limit x approaching -2 from the right. Do the same thing. Plug it in. -2, sorry. I can do 2 times -2 plus 2. -4 plus 2, so this would be -2. Let's compare. I have -1 for the left, -2 for the right. So is there a limit for this one? D and E, yes. So you can say the limit is D and E. Why? Because it's not the same. Okay. So you need to compare the left and the right limit. If they're not the same, there's no limit. If they happen to give the same number, then yes, you can say, yeah, there's a limit right there. Okay, let's do another one over here. Let's do another one. Same thing. Okay, how do I know which values to plug it in? Well, this one right here will tell you. Okay, the one that say x less than, x greater than, something like that. So I can write out limit x approaching 1 from the left. Okay, so f of x equal to, so 1 square plus 2 times 1 give me 1 plus 2 is 3. Then I'm doing the same thing, but now it's in the right. So the plus represents the right limit. Okay, plug it in. This one is 0. So the reason I chose this one, because think about this. This one is 0. I don't have any x values to plug it in. So I'm not going to plug it in. So the limit on the right side is 0. The left side is 3. Is there a limit for this one if they don't match? No, D and E. So this is the proper way for you to write it. You can say limit x approaching 1, f of x equal D and E. So that's the proper notation. So something that you may forgot. Okay, so the left limit, the top right here is the negative. The right limit on the top side of the 1, there's a plus. So this is the left limit, this is the right limit. So this is limit for piecewise function. That's another thing that I want you to go back and review. How we feel about this? You want to jot this down, or you want to go back and watch the video as you do in the work, that is fine. No problem. For some of you, it's like, I feel confident. I think I remember. I know what to do. the work is already posted for you in KudoWorks and you can start. But I think my suggestion is if you can stay with me for the limit, it will be useful for you to stay and review limits with me because it's been a while. But derivative, that is new, and I think most of you remember, and that's fine. You can start ahead of time. You don't have to wait for me. But stay for the limit, okay? All right, piecewise functions. And then this is the third one that I want you to know for the limit. It's called removable discontinuities. For this one, it's involved with you have to factor out the expression and then cancel something. The thing that you learned on this Wednesday, no, I will not put that on the test. I figure I just gave you the notes. I'm not there to answer questions, so no. Whatever you need to know for the test is on this document. This is the review. All the question I put it here. That is what you need to know for the test. Okay? So if you're like, okay, this objective, I got confused, I don't know how to do this problem, then see me for office hour for the next couple of days. Yeah. The one that I post on Wednesday is kind of fun. I love that kind of problem. It's fun to do, but I don't think it's fair to test you on that, so I'm not. Okay. All right, so removable discontinuity, if some of you may remember, some may not, what I need to do is I need to factor out anything that I can factor. So the top, I cannot factor, so just x plus 2. But on the denominator, look at this one. I have x squared minus 4. That would be x minus 2, x plus 2. So this is involved with you factoring method. So what you really do is you're going to factor out one of the expression. I have office hours at 12:45 on Monday. So any of you need to, 11:55 on Monday. If you guys need to see me, yes. Grade is due on June 1st. So we have next week to see me during office hour if you need to make up anything. All right. So if you can make it this week for some reason, we have next week office hours to do it. Okay. So does anyone remember what I do once I factor out the denominator? If you remember what we do. What would be the next step and why? Just think about why I have to factor it out, and that would help. I need to simplify, right? So this is x plus 2, cancel out. So I will have limit x approaching negative 2. So the x plus 1 cancel out, so that would be 1 over x minus 2. So now what I can do is you can cancel as removable, yes. But for this one, I'm just asking for the limit. I'm not testing you on discontinuity, so we're not going to talk about removable or non-removable, but you are right. If you can cancel out the factor, it is removable. So now I'm going to plug it in. The x values, negative 1 over negative 2 minus 2. So that's negative 1 over negative 4, which is 1 over 4. So this is the limit. Office hours 12:45 today. If anyone needs to see me today, yes, 12:45. All right, questions for me on this removable discontinuity. Let's do another example. Okay. Let's do the next one right here. Write this. So step number 1. The one on the top, I don't have to do anything because it's already simplified. But on the denominator, that's something that I can factor out. So I'm going to move the screen a little bit. Okay. I can factor this one out. So this will be, if you have problem with factor or quadratic function, then see me if I helped. This one will be negative 1 x plus 2. A lot of time the denominator, one of the expression will tell you exactly what you need to cancel out. So in here, I can cancel out the x plus 2, limit x approaching negative 2, negative 1 over x minus 1, plug it in. Oops, negative 2 minus 1. Be careful with the negative, okay? This is negative 3, so the answer is 1 over 3. Be careful, because a lot of you make mistake because you didn't pay attention to the negative in the front. So this is how you find the limit for removable discontinuity. You factor it out, cancel the common term, and then you can plug it in the values. Questions? How we feel about this? Good. Okay. So that is the limit. The rest of the question we have, I'm going to kind of give you like just a quick overview of what we do with derivative. So derivative is power rule, which is really simple. A lot of you remember what to do. For this one is f prime. What we do with the exponent is we take the exponent, bring it to the front, times 5x, and then the power minus 1. 15x minus, so this is 15x to the second power. So this is derivative. So derivative, take the power, move it to the front, and then the power minus 1. So we should have a bunch of those practice for you. Now, another one that I want to go over in practice is when you have like a bunch of terms put together. It's going to be the same thing, okay? F prime. Again, you take the power to the front. Do you have to write all of this one out? Probably no. I just write it just so that anyone was like, I have trouble, I don't remember, then you can use it. So this 4 times 2, x 4 minus 1 plus 3 times 5, x 3 minus 1. I'm going to go over this one a little bit fast because I think we just covered. You just had a test on this one, but let me know if I need to slow down. 25 x to the 4th power plus 8 to the 3rd plus 15 x to the 2nd power. Do you have to do these steps? The one that I just highlight? No. For some of you, you can do mental math and you're like, okay, 5 times 5 is 25. It's going to be 1 less. So you can totally do that. You can skip the line that I highlight in yellow. You can skip that line. Questions for me when we have positive powers. At this point, it's all about derivative and antiderivative. So if you feel comfortable to do the work without waiting for me or go through the examples, then go ahead and log into KudoWorks and start the review. Or you can do the PDF, it's up to you. Okay. If you need to copy down notes, let me know, I'll wait, and then you can copy down the notes or go back to certain problems so that you can take notes. But for those who just joined the class, I'm recording this lesson so you can go back and watch it. Okay, what if you got a fraction as a coefficient? What if you get that one? It still work out the same way. Bring out the 2's to the front. 3 over 2, x2 minus 1. So 2 times is going to cancel out. There's a negative, so this is negative 3x to the first power. Or you can do negative 3x. Same thing, nothing changed. You just take that exponent and multiply with a fraction. Same thing. So if as I'm doing these problems and you was like, I don't know any of these, I'm going to say, Miss Wen, if you need me to tutor you today, you can come and see me at 12:45. If not, Monday, Tuesday, Wednesday, Thursday, and Friday next week. Even though you're done with your final exam, you need to bring up your grade. You should be able to see me if anything you miss. But make sure you do it, okay? All right, so that is derivative, and then we look at trig function. Trig function. Okay, I'm going to cross out number 2 and number 23 because we have not learned how to do that yet. Actually, this is change rule, so I have not teach you how to do it. So let's not look at trig functions. Skip the trig function in your practice. The final exam is on the topics that I'm giving to you. So I'm going to cross those problems out, but for the derivative of cosine, okay. The one that I'm posting for you is not, but I'm going to review trig function, and you should know trig function. Who remember what is the derivative of cosine? Negative sine, yes, correct. So it's going to be negative 5 sine. If I have a function like this, negative sine, what is the derivative of sine? Positive cosine. But since this one is negative, so I can have negative cosine of x. Yes. Okay. So the derivative of sine is cosine. The derivative of cosine is negative sine. Let's not do subplan. So for the subplan for 519, let's not do it. Let's not do it. Okay. Just do the final exam review. The semester exam review. Just do that one. Okay. The subplan for the May 19, if you didn't do it, that's fine. If you did do it, great. You have extra practice, but if you didn't do it, that's okay. All right, this is the most recent, the evaluation of indefinite integral is this one as we go backward. So let's review. How do we know when we have to go backward? Look at this notation. That curve tell you that this one is antiderivative. Okay, what we do, we go in backwards. So in here, the 25, I still use that. But what we do with the power is x plus 1 over the same thing that I have over there. So 4 plus 1, right? I divide by the same thing. So if we look in here, 25 x to the 5th divided by 5. Simplify, so 5 x to the 5th plus c. Don't forget the plus c. I just forgot the plus c, so that means it's really easy for you to make that mistake because you forgot the plus c. Okay, so plus c, plus c. So that's the difference. So this one is antiderivative, so that's different a little bit. Is this something you want me to review more, or you feel like I got the antiderivative? I'm good. A little bit more. Okay, so I have some of you say I'm good, some of you review more. So if you feel like I'm good to go, I can do it. Like I said, go ahead and log into KudoWorks and do it. You need to review a little bit more, then stay with me in Zoom, okay? Don't log out though, just stay quiet and go to KudoWorks and do the practice, and then you can check in, or you can just stay with me, watch me to do the next couple of examples, okay? All right, for this one, if it's just a constant, it turns into x plus c. Don't forget the plus c, okay? If you have something like with a bunch of numbers like this, you will do the same thing. So 5x, right? The power plus 1 over, I'm dividing the same thing. 3x2 plus 1 divided by 2 plus 1 plus, if it's just a constant, it turns into 4x. Don't forget the plus c. The dx just tell you that is the derivative, so you don't have to do anything with dx. Dx say this is the derivative function. So when you go backward, I'm going to go back to the original function, so I don't need the dx anymore. So I'm going to, this is 5x2, 5x to the 5th divided by 5 plus 3x to the 3rd divided by 3, 4x plus c. I can simplify this one because the 5 will cancel out. So x to the 5th plus x to the 3rd plus 4x plus c. Okay. So you guys can just do the practice so that you know, like, okay, this is the one that I got struggle. I didn't do well with this objective. I should see Miss Win for it. Okay, I'll give you a few seconds to copy this down, and then we'll do the last topic, the last objective that I want you to know. So I'll give you, you can copy this down, and then we'll finish up. Okay, we can do the one with the negative power. It's going to be the same thing. So negative 2, x negative 2 plus 1 over negative 2 plus 1 minus 20, x negative 5 plus 1 over negative 5 plus 1. Don't forget the plus c. We do the same thing. Even though it's negative, it's okay. You just apply the rule. So negative 2, x to the negative 1 over negative 1 minus 20 x to the negative 4 divided by negative 4 plus c. So negative cancel out. So I have 2x negative 1 minus, this is negative, so turn into positive 5x to the negative 4 plus c. But keep in mind, we don't like the negative, right? We cannot have negative exponent, so just bring it down. So we bring it down. So it's turned into x on the bottom. So you have a bunch of those to practice. So if you see this notation, the integral notation, that means you need to go backward. You do the plus. Okay. This, you can think of this as the s. So that means it's a sum. I will add it. I will add the exponent. The last one that I want to review with you is find the equation of a tangent line. And I think this one you guys did well on your test. So step number one, I'm going to take the derivative. 4x, the 2 cancel out. Step number 2, I want to find the slope. So 4, I will plug it in. This value is right here, -1. So my slope is -4. Step 3, if it's a multiple choice, then you want to simplify all the way, which some of you did on your test. And what happened is when you simplify all the way, you make mistake. And I have to take out points. So unless it's a multiple choice and it is in slope-intercept, then you simplify. Otherwise, let's not. You can stop right here. Remember this formula, y minus y1, mx minus x1. Plug it in and stop right there. Don't do anything further if that is the short response. So y minus 4, -4, x minus -1 or +1. Okay. If it's a multiple choice, then yes, you want to simplify all the way. So this is what we're going to do. Let's review a little bit. Distribution, -4x minus 4 plus 4 on both sides. Y is -4x. The 4 and -4 cancel out. So this is my tangent line. This is the equation. So if I don't ask you to, if it's not the multiple choice, you can stop at the line that I just highlighted for you, and that is fine. Don't simplify further because you may make that mistake. If you're confident with your algebra skill and you'll be okay, then that's fine, no problem. I'm not going to stop you. But you're like, I don't know, what if I make that mistake? Stop at step 3, right here, the one I just highlighted, and then you'll be fine. Okay? All right, I'm going to pause for you to take notes, and I'm going to ask you to tell me which topics that you want me to go back and review a little bit more.